Welcome to the Global War Watch Network. Today we are talking about something straight out of science fiction, but it's quickly becoming science fact. We're talking about self-healing materials.
Just imagine this for a second. In the skies of the very near future, our most advanced jets won't just be flying, they'll be adapting, almost like they're alive.
I mean, picture wings that can literally bend and reshape themselves in the middle of a flight, or stealth skin that can regenerate damage just like our own skin. Now, this isn't a movie plot. This is the incredible promise of self-healing technology. And today, we're going to break down exactly how these amazing materials work and why they're about to completely redefine aerospace as we know it. And hey, if this is the kind of insight you find valuable, you're going to want to subscribe to the channel right now to stay ahead of the curve.
So, let's get into it. Where did this mind-bending idea even come from? What does it actually mean for a piece of metal or composite to heal itself?
Well, the inspiration comes directly from nature, from us. As our source material puts it, it's a lot like how we heal. You get a cut, your body immediately senses that damage, and it kicks off a whole automatic process to repair itself. These materials are being engineered to do the exact same thing, but for things like an airplane's wing.
All right, so what are we really talking about when we say self-healing composites? Let's get a really clear definition.
Okay, so these aren't just ideas on a whiteboard. These are actual advanced materials that are designed to fix themselves all on their own. And the real genius here is that they stop catastrophic failure before it can even start. They tackle the tiny, almost invisible microcracks that build up over time from stress and just wear and tear.
And it turns out there are a couple of different ways to do this. You've got two main flavors here. First, there's autonomic healing. That's the one that's completely automatic, just like a cut healing on your arm. Super useful for parts of an aircraft that are really hard to get to for repairs. Then you have non-autonomic healing. This one needs a little push, an external trigger like heat or UV light to get the repair process going. This gives engineers a ton of control over when and where the healing happens. So how in the world do these materials pull off this incredible trick? Let's look at three of the coolest methods out there. These are what scientists call extrinsic techniques, which basically just means the healing stuff is preloaded right into the material.
Let's start with the most common one, called microencapsulation. The concept is actually beautifully simple. You've got millions of microscopic capsules, like tiny, tiny balloons, scattered throughout the material. Each one is filled with a liquid healing agent. As soon as a tiny crack starts to form, it breaks open these capsules. The liquid immediately flows into the crack, it hits a catalyst that's already mixed into the material, and then it hardens, basically gluing the crack shut from the inside.
But here's the thing with those microcapsules, they're a one-and-done deal. Once they pop, they're used up. So to solve that, engineers are working on some seriously advanced systems. Think of hollow fibers or even interconnected 3D vascular networks woven right into the material, almost like a circulatory system. These can deliver a continuous supply of the healing agent, which means the part could heal itself over and over again in the same spot.
Now this is where it gets really exciting. Let's look at what this technology means for the aerospace industry. We're talking about a genuine revolution here, with huge implications for safety, for maintenance costs, and for the lifespan of an aircraft.
And we're not just talking about one or two parts. This tech is being developed for pretty much the whole aircraft. Everything from the main fuselage and wings, all the way to the hottest, most extreme parts of a jet engine. They're even creating protective coatings that can heal themselves from scratches to stop corrosion right in its tracks.
To really get why this is such a game changer for aerospace, you have to understand the materials themselves. Composites are just amazing. They're what you get when you combine different materials, like weaving carbon fibers into a resin, to create something way better than the sum of its parts. And this chart right here shows you everything. It's looking at specific strength, basically how strong a material is for its weight. And look at that epoxy carbon fiber compared to traditional metals like titanium and steel. It is off the chart strong for how little it weighs. And in aerospace, that is the golden ticket. It's how you make planes lighter, faster, and way more fuel efficient.
So, the big question is, does this stuff actually work? Oh yeah, it works incredibly well. Studies have shown that composites using those hollow fibers we talked about can recover up to 97% of their original strength after being damaged. Just think about that. That is an absolutely staggering level of regeneration.
And if you thought that was impressive, wait till you hear this. Inside a jet engine, you're dealing with insane environments, temperatures over 1,000 degrees Celsius. So for that, scientists are developing special self-healing ceramics.
When a crack forms, the material literally uses that intense heat to create a glassy layer that seals the damage. This lets engines run hotter, and hotter means more efficient. It's brilliant.
So where is all this heading? What does the future look like? We're not just looking at a slightly better material here. We are on the edge of a fundamental shift in how we think about the stuff we build things with.
You see, the future isn't about finding one single miracle material that does everything. No, it's about applying these self-healing ideas across a whole range of materials. We use polymers for lightweight parts, smart metals for the components that take the most stress, and these advanced ceramics for the super-hot engines. The goal is to build smarter, tougher, longer-lasting systems into every single part of an aircraft.
This technology is really pushing the absolute limits of engineering. It's blurring the line between a static machine and a living, breathing organism. Which leaves us with one final, very provocative thought. As our materials begin to live and heal, what on earth will we build next?
Thank you so much for joining us for this explainer. If you found this as fascinating as we did, please hit that like button, share it with someone you think would be interested, and of course subscribe to the Global War Watch Network for more deep dives into the technology that is shaping our future. We'd love to hear your thoughts in the comments below, and you can join the conversation on our social media channels. All the links are in the description. Thanks again for your time,